Okay guys, here are the instructions on how to make what I need you to make. Okay, you ready? You have 4 pieces of paper, whatever colors you chose. Okay, so let me zoom out just a little bit so you can see this a little bit better. Okay, so I'm lining the papers up like this. Can you see that very well? An inch to half an inch, something like that. Okay. Now watch what I do. I'm holding the top, but I'm going to tuck the bottom underneath. So when I fold, it's going to look like that. Does that make sense?
Oh, I think we did this in Coach Waters' class.
Yeah, you might have done it in another class. Yeah, it's an interesting foldable. Okay, you can use it for a lot of different things. Okay. Now you want the same color showing twice. You don't want the same color just completely on top of itself. Okay. And then I'm going to take the stapler and I'm going to staple it 3 times. 3 is probably a good number. 2 is probably okay. Probably don't need 8 staples in it though. Okay. Now, depending on what colors you chose, pencil may not work very well for you. Okay? If you chose any dark colors, pencil may not work very well for you. So if you want to use markers or colored pencils for this today, that's fine. Okay? My markers are back here on my desk if you want to come grab one of them, or 2 of them or something. Okay? As soon as you get it put together, and it doesn't even have to be stapled to do this, I want the back. I want your name on the back. Because if you happen to have this foldable with your name on the back, it can be used on your test on this unit. Okay? Yeah, gotta have your name on the back. And I would prefer your name in pen, honestly.
What about markers?
Not that anyone would erase someone else's name and write their own name to try to be able to have one to use on the test. Not that that's ever happened. Yeah, it has. Okay? Marker is totally fine. Anything you can't erase. Okay? To write your name. Okay? That's okay. Go ahead. Get it sharpened. Oh. Hey, try the other one.
Try this one over here.
You have 3.
I have 3 what?
Pencil sharpeners.
Yeah, but this one doesn't work at all. I don't even know why I keep it in here. I'm glad you're back. I'm sorry you didn't get to go play. It breaks. It's okay. It breaks.
Okay.
Do I need to fix it? Do I need to fix it for you?
Yeah.
Let me have it.
Everybody see it, so let's keep it going.
Everybody seen it?
No, it's funny.
I want to do that.
Thank you.
Sausage.
Are we almost ready? Wait, are y'all the only table that's used the stapler so far? They're so slow.
Brandon broke it.
Oh yeah.
Seriously, Brandon?
It's all my fault.
Mine is.
I didn't even go through.
Oh no. Well, we can do the first part with or without a staple, so I'm going to get you to write the title on this front page right here. Okay?
This big part?
Uh-huh. Exponents.
Oh, okay.
This is the top flap. Okay?
Is that all
Exponent. That's all we're writing on that part. So you can make it as big or as small as you want. Okay? I mean, if you want to put like a smiley face or something like that, you can. Because exponents are exciting. I mean, math exciting. But
Put an exponent smiley face.
right there.
The third.
Okay, so if you haven't seen this foldable before, first of all, if you have seen it before, you know how this works, right? If you haven't seen it before, we're going to be writing on this edge right here, on this tab, okay, on the tabs that are here, and then when we fold the next paper up, we have a lot of room to write different examples and different rules and stuff like that, okay? So the words here on the tab will be talked about on the part underneath. Does that make sense? Okay? I guess it probably would help if I had another stapler today. Right? Okay. One that some people don't break all the time would probably be helpful.
Yeah, I don't break that. Oh, yeah.
Okay, well, almost when everyone's almost finished, I'm going to go ahead and write some of the names on the tabs so we can at least get started a little bit. Product of powers. It says product of powers. What does product mean? Multiplication. And powers? Exponents, right? Okay. Product of powers. Because what are we doing today, after all? What are we doing? Today I will remember more facts about exponents. Yesterday, especially for those of you who weren't here yesterday, we talked a little bit about facts about exponents, how you deal with exponents when you're multiplying like bases, when you're dividing like bases, things like that. We're going to go over those today with this foldable, and we'll go further. We'll talk about the few more rules that we didn't talk about yesterday. Okay? Let me see if I fold this up, if that'll help a little bit. Slightly. See, the hard part is on my screen, it's a nice, really pretty bright green on my computer screen. So I don't know why it's so dark up there. I'm sorry about that. Okay? It's not going to help, so I'm just going to fold that back down. Okay, the other thing that needs to be on this tab right here is the actual rule for product of powers. And the rule is a to the m times a to the n equals a. What did we decide yesterday? If we're multiplying like bases, what do we do with the exponents? We add them. So m plus n. That's weird that with my hand up there you can read it. It's like I have some sort of magical powers in my hand.
I think you do. Actually, with the light reflex.
Swamp gas? Is that what it is?
Oh,
Okay.
that last one was a good one.
Okay, we good so far on that? Alright, so go ahead and fold up that top flap. Let's write some examples for ourselves here. Okay? So some examples here are x squared times x to the third. X squared times x to the third. What is that going to equal?
X to the fifth.
X to the fifth. Because when we're multiplying like bases, we add our exponents. Okay? Those of you who were here yesterday, what did we introduce as far as exponents go that you haven't seen before? Fractions. Okay? Now, it's not, for those of you who weren't here, it's not as hard as it seems. Am I just pretending that? Or those of you who were here, back me up.
It was pretty hard.
Shut up. It was pretty easy, right? Okay? So does the same rule apply if we have fractions in our exponents? X to the 3 halves times x to the 4 halves. What's that going to equal? X to the 3 halves times x to the 4 halves. X to the 7 halves. We're just adding our exponents. When you add fractions, you have to have a common denominator. I do, so I add the numerator, keep the denominator. Done. Do I need to show you more examples of that, or are you okay? You good? Okay. So our next rule then, our next tab is power of powers. Power of powers. What do you think I mean by that? Product of powers meant we were multiplying like bases, so we have to add the exponents. What do you think power of powers? What? Yeah, that's exactly right. Okay? So what it looks like is a to the m, but that's in parentheses, and that's being raised, does that help? That's being raised to the n power. And what do we do when we're raising a power to a power? That's not one of the things we talked about yesterday, is it? Okay, I don't think we looked at that at all. Maybe we did. What do you think? Multiply. A to the m times n. Okay? So what kind of examples are we going to look at for that? Well, if we have x squared to the third power, what do we do with those numbers? Multiply, so I get x to the sixth. Now, as a matter of just let me show you really what is happening, x squared 3 times, right? I have an x squared 3 times. So I have x squared times x squared times x squared. Well, following the previous rule, what do we do with the exponents? Add them. 2 plus 2 plus 2. X to the 6th. Do you see how we got the same answer? This is the math that's going on behind this rule. Fair enough? Okay, so my next question is, does it work for fractions? X to the 1/2 being raised to the third, what should that equal? X to the 3/2. Everybody clear on why that's true? Okay? Any questions? Okay. Next rule. What do you suppose this color is, by the way?
Yellow.
Yellow. It is yellow. Isn't that weird?
It looked yellow with the green down.
Yeah. With the green down, it'll change in just a second. No, it's weird. Anyways. Okay, so the next rule. Power of a product. What?
He was asking if we could switch the lights.
Yeah, you can try it. Power of a product. What do you suppose this has to do with? Power we know is exponent. Product.
Oh, would that be squaring? Is that better or worse?
It's worse because I can't, like the recording I can't see anymore. Oh, this light didn't come all the way back on.
I broke it.
Yeah. Okay.
Is it broken?
That's weird. Okay. Power of a product. Did we decide what you... Did you guys decide what that meant?
We tried.
An exponent after multiplying.
So we're multiplying and then an exponent?
Yeah.
Yeah, absolutely.
Multiplying it.
A, B to the n power. Let me move the blue and see if it'll look yellow. And not orange or whatever color that looks. Put my hand there. Nope, that didn't work. Oh well. What do you think this is? What is being raised to the n power? A and B, right? So A to the n, B to the n.
So you don't multiply first.
Well, they're different numbers, so you can't. You know what I'm saying? Especially if they're A and B, you are multiplying them by saying AB. You know what I'm saying? If they're variables, stuff like that. Okay? Good question, though. So, what kind of examples are we going to have? What are they going to look like? I want to have a couple more examples this time, so if you were writing your examples really big, you may want to shorten them up a little bit. Okay? AB squared. We'll start off really simple. AB squared. What's that going to look like? A squared, B squared. Absolutely. What about x squared y cubed to the 4th power? That's exactly right. X to the 8th, y to the 12th. Because of the rule that we just talked about, right, the power of powers rule, if something's being raised to a power, a power is being raised to a power, you multiply. Well, these already have powers, now we're raising them to the 4th power, so we multiply those numbers. Right? But it's everything, isn't it? Okay? So 2xy to the 5th raised to the 3rd power. Don't be tricked, don't be tricked, don't be tricked. What's first? Okay, you remember that part where I said don't be tricked? What is being raised to the 3rd power? Everything. Even the 2. Even the 2. Okay? So it is 8, because 2 to the 3rd power is 8. X to the 3rd. Perfect. Y to the 15th. Okay? Guys, even the numbers are being raised to the power, because they have powers also, don't they? Isn't it 2 to the 1st power? So 1 times 3 is 3, so 2 to the 3rd power is 8. Yes? Okay? Another way to look at this is the way kind of that we looked at this one right here, where I expanded it for you a little bit. If I rewrote this problem right here, it would look like 2xy to the 5th times 2xy to the 5th times 2xy to the 5th, right? Well, then it's a lot easier to see that it's 8, isn't it? Okay? There's 3 x's, so that's going to be x to the 3rd, and there's 5, 10, 15 y's. Fair enough? Okay, so what's my next question? Does it work with fractions? AB to the 1/2 power. What you got? A to the 1/2, B to the 1/2. Those of you who were here yesterday, please tell the people who were not here yesterday what it means to be to the 1/2 power. Close? Square root, right? So the 1/2 power means a square root. And that's something we'll write in on the last page, just so you know, okay? We'll get there. Okay, or let's do one more. 16 a to the 5th b to the 1/2 power. What's being raised to the 1/2 power? Everything. Wait. What do you mean 4?
The square root of 16.
Oh, the square root of 16. So we don't have to write 16 to the 1/2 because we know it, right? And then A to the 5/2. B to the 1/2. Excellent. Why is A to the 5/2? It was to the 5th, and that's being raised to the 1/2. And what do we do with these two exponents? Multiply. Okay? Any questions? Next tab. What?
Gotta start off in cursive in this one.
Sorry. I get picked on by my afternoon classes because they can't read my cursive. They say it's too messy. So I try to print. Okay?
I can do it.
So what do you think the rule is for quotient of powers? What's a quotient to begin with? Division. Okay. So yeah, that's exactly what it looks like. I'm not going to draw that. I'm just going to actually write the letters. Okay. So a to the m over a to the n. A to the m over a to the n divided by a to the n. When we're dividing like bases, what do we do with the exponents? Yeah, we talked about that yesterday, didn't we? A to the m minus n. Okay? Let's do some examples. X to the fifth divided by x to the third. X to the second. X to the third divided by x to the eighth. This is really kind of a mixture with a tab that's 2 away, so I'm going to kind of talk about that tab a little bit before we get there. And that tab is called negative exponents. Do we have negative exponents?
There it is.
There's the light. We don't have negative exponents. Okay? And so one of the ways that we counteract that is by, when we do the subtraction, where should we start? Shouldn't we get to choose? Yeah. Can we start in the denominator? What's 8 minus 3? 5. Where did we start, though? So wherever we started, that's where we have to leave the answer. Does that make sense? Okay? Because that's what we did up here, really. 5 minus 3 is 2, and I left it in the numerator. We just didn't draw it that way. You know what I'm saying? We could have drawn it like that if we wanted to, so that it's still in the numerator. But you know that x squared over 1 is just the same as x squared. Okay? Next question. Does it work for fractions? Does it? This is supposed to be a 3. X to the 5/3 divided by x to the 2/3. X to the, wait, why do you want to go right to 1? Oh, 3/3. Can I write that step since we're just now starting? And now we can go here. And we don't even have to write the 1 if we don't want to, correct? Okay. Next tab, you ready for it? Look, it finally looks yellow now that we're done with it. Power of a quotient. What do you think that looks like? Dividing it and then raising it to a power. That's exactly right. Okay? Dividing it and then raising it to a power. So what's the answer? What's being raised to that power? Both of them, right? So a to the m divided by b to the m. Oh. Okay, so far? All right, some examples. So starting off very simply, x over y to the third. Perfect. X to the third over y to the third. You know, this crazy kid earlier said x cubed over y cubed. What did I say? Okay. Right? Different terms, meaning the same thing. Okay. What about this one? A to the 6th over b squared. All of that being raised to the 4th power.
A to the
A to the 24th, B to the 8th. Good. Can I try to trick you?
Sure.
Okay.
No.
Oh, good one.
3x over z to the 4th, all that being squared.
9x
Oh, good. You didn't let me trick you this time.
squared.
Where do you think the trick was?
The 3.
The 3, right? The 3. Everything's being squared, not just the exponents on the variables. Okay? So, does it work with fractions? Even awful fractions like 5/7? X to the 5/7 over y to the 5/7. Two x to the 4th over y raised to the 2/3 power. What you got? So what I hear is that you're trying to do something with the 2. You don't want to leave it just as a 2, right? You know you got to do something to it. But because I don't know the cube root of 2, sometimes it's okay to just leave it like that. Okay? What is x, though? Nope.
Oh, no, it's not it.
8/3. Yep. Good try. Y to the 2/3. Okay? Next tab. Is negative exponents. And the rule for negative exponents is a to the negative n equals 1 over a to the n. Right.
So she made it positive.
Yeah.
By putting
Oh, thanks for that.
So if it's in the numerator, where's it going to go? To the denominator, right? What happens to the exponent when you move it to the denominator? It's a positive, right? Okay. So let's do some examples. So again, starting out real simply, x to the negative 3rd power equals 1 over x to the 3rd. Does it work the other way though? 1 over x to the negative 4th power.
X to the 3rd.
Yeah. Wherever it is, it doesn't want to be there. Right now, it's in the numerator. It wants to be in the denominator. You're a kind person. You move it there. Now it's happy. It's in the denominator. It doesn't want to be there. When you move it to the numerator, now it's happy. Is that stupid? Yes. But you'll remember it.
What's the thing you put down at the bottom?
I haven't put it just on the tab. Negative exponents. Yeah, sorry about that. Okay. All right. So can I try to trick you? Okay. Negative 2x squared y to the negative 3rd. Okay, so I know I've tricked at least one of you.
Do it.
Oh, you got tricked.
X
No, he didn't.
squared.
It wasn't him. It was Jason. Why did he get tricked? What moves? What do you want to make happy? Negative exponents, not negative numbers, right? The negative number, we're sad that it's negative, but we don't do anything about it, right? Does the x want to move somewhere else? No, it's happy where it is. Does the y want to move somewhere else? Where does it want to move? And when it moves, now it's happy. Again, is that stupid? Yes, I know it is. Okay? The rule is negative exponents go to the other side, right? It's either denominator to numerator or numerator to denominator, and when it moves, the sign changes, right? Making things happy and stuff like that is a stupid way to remember it. Okay? So what about this one? 3xy squared to the negative 4th power.
1 over 12x4y8.
Really close. No, it's not. What is it?
27 times 4.
81.
Nice.
That is a mistake that some people make, though, because they just see that as a multiplication problem and want to write 12, right? So we know we're moving this to the denominator. I guess I could have written another step there, right? We know we're moving this to the denominator, and then we're raising it all to the 4th power. So x to the 4th, y to the 8th, right? Is that the only way to do this problem? Is that the only way to do this problem? We could have said 3 to the negative 4th, x to the negative 4th, y to the negative 8th, couldn't we? And then simplify that to 1 over 81, x to the 4th, y to the 8th. There's not just one way to do negative exponents. Okay?
Or
X to the negative 1/2. Does it work with fractions?
Oh, yeah.
So what is it?
x squared.
1 over x to the 1/2. 1 over x to the negative 3/4. X to the 3/4. Okay? Now, you got that? Okay, sorry. Yes or no? Okay. So our back page is just some notes for us. What'd you say? It did? Okay, thank you.
Oh.
Our back page is just going to be some notes. That's our tab. It's just some notes. Okay? And our major note, well, we've got kind of two major notes. Okay? But our first major note is this. I chose A on purpose instead of X or Y or any number that we normally do. I know I've been using A on some of the other ones, but I chose A on purpose because I really want you to think of A in this case being anything. Okay, I know X can represent anything, B can represent anything, all sorts of stuff like that. But what is anything to the 0 power? 1. Anything to the 0 power is always 1. Okay? But more importantly, some stuff that we learned yesterday, x to the, what do we want to call this? M over n power. The bottom number of a fractional exponent represents what? You remember? The root, right? The root. And the top number represents what? That's the power. Here's what I mean by that. 7 to the 2/3 power. How can I rewrite that problem? Well, what root is it? The cube root of 7 squared. That's exactly right. Okay, now I'm going to attempt something. I'm not very good at drawing, but you already know that. I'm going to attempt something just in case there's still somebody in here who are struggling with this one. And possibly even struggling with exponents, or the negative exponent, excuse me. Okay? 2 to the first power. Isn't that just 2? It's just 2 blocks, isn't it? What's 2 squared? Isn't it 2 of these? Right? So this is 2 and this is 4. Isn't it 2 of these? Right? Because I've multiplied by 1 more 2. So it's this one and this one. That's 8, right? I'm going to finish it on the video so you can go watch it and have it if you want it. Can I show you this real fast? What's the pattern going this way? 8 to 4 to 2. I'm dividing by 2. If I divide this by 2, I just get 1. If I go 1 more, if I divide that by 2, what do I get? I get half of that, don't I? And if I divide that by 2, I get half of that. So this is 1, this is 1/2, and this is 1/4. Okay? Do you think that might help a little bit? I hope so. I hope you have a wonderful day. Peace.